Hello and welcome back. Now, in the previous module, we discussed the AWS Cloud Adoption Framework, which is a set of prescriptive guidelines and foundation capabilities that companies adopt to expedite their digital transformation journey. The Cloud Adoption Framework looks at it from an overall business perspective. What processes and methodologies are going to be incorporated to help the business become more agile and competitive in a digital age. In this module, we're going to move on and discuss the AWS Well Architected Framework, which is a framework that comprises of 6 pillars to help you design, build, and deliver robust, reliable, highly efficient, scalable, and cost-effective solutions in the cloud. So this is more focused on the actual application architecture, the solutions, and the services that you're designing and building for your clients and customers. Let's take a look at the well-architected framework in this module. Now, when designing, building, and deploying your solutions in the cloud, you want to ensure that your product or service is constructed following security best practices, is highly resilient, makes use of efficient infrastructure, is high-performing, and cost-effective. To help you achieve these goals, AWS offers a series of best practice guidelines and recommendations centered around 6 key pillars. So we've got the operation excellence pillar, the security pillar, the reliability pillar, performance efficiency, cost optimization, and the sustainability pillar. Let us look at these pillars in some more detail and how they can help you design and architect solutions that are highly robust, secure, reliable, high-performing, cost-effective, and sustainable for the environment. So we'll start off with the first pillar, operational excellence. And specifically, we'll look at the design principles around operational excellence. Now, operational excellence is all about building application solutions correctly while ensuring excellent customer experience. This pillar is designed to help your team focus more of their time on building feature-rich applications, on product enhancements and customer benefits, rather than maintenance and firefighting. The aim is to deliver new features and bug fixes quickly and efficiently to the customer, requiring agility and an adoption of DevOps principles such as CI/CD for your application lifecycles. Now, when it comes to design principles, the first recommended principle is performing operations as code. In much the same way as you could build applications using code, in much the same way as you would design your infrastructure deployment stacks as code using infrastructure as a code platform such as CloudFormation or Terraform, you should consider building operation procedures and processes as code, automating them and delivering them based on events that are triggered. This is one way of ensuring that you are always on top of the game when it comes to operational issues around your application architectures. The next one is all about making frequent, small, reversible changes. You want to implement a process of making regular, small changes that are reversible so that you can get back to a previous state if things don't go according to plan. You want to make these changes frequent and small so that you don't end up building up a series of changes and making a massive change at the end of the year or something. This all adds to the burden and administrative overhead, but also when things do go wrong, it's quite often difficult to try and fix those issues and identify where the problem lies. So making frequent, small, reversible changes is an ideal approach when you want to ensure operational excellence. Next, it's all about refining operational procedures frequently. Now, this is all about ensuring that you evolve your workloads and your operation procedures in accordance with your workloads. You want to make sure that you hold regular reviews and validate all of the procedures that you have in place, whether they're still valid, whether they still fulfill the requirements. You also want to consider gamifying your operations to share best practices and educate your teams. Next, we have anticipating failure. This is where you want to perform something called a pre-mortem exercise so that you can identify sources of failure that can be removed or mitigated. You want to test scenarios and validate your understanding of their impact. And using regular game days, you can actually test your workloads and processes and how you respond to various simulated events. Next, you want to learn from operational failures. You want to drive improvement through lessons learned from all operational events and failures, and you want to share those lessons with your entire organization. We also recommend that you consider using managed services. This reduces the overall burden from an administrative perspective if you're trying to build solutions where you have full control over the infrastructure. So for instance, opting for something like serverless architectures versus server-based architectures is a prime example. And then finally, you want to implement observability for actionable insights. You want to gain a comprehensive understanding of your workload behavior, reliability, cost, health. You want to define KPIs, key performance indicators, that allow you to make informed decisions and take prompt actions when business outcomes are at risk. You want to proactively improve performance, reliability, and cost based on actionable observability data. Next, let us move on to the security pillar, which is all about ensuring high levels of security at all levels of your cloud journey, ensuring you deliver robust and secure applications to your clients and end users. It focuses on how you can ensure business and regulatory requirements are fulfilled by following AWS recommended best practices. And using these recommendations, you are able to build architectures that protect your data and systems, control access, and respond automatically to any security events. Let's take a look at some of the design principles that fall within the security pillar. So the first one is implement a strong identity foundation. This one is all about ensuring that you apply the principle of least privilege and enforce separation of duties with appropriate authorization for each interaction with your AWS resources. Next, we want to maintain traceability. Now, traceability is all about monitoring, alerting, and auditing actions and changes to your environment in real time. And you want to maintain this log of data in order to be able to carry out any necessary investigations and also perform automatic analysis of what's happening within your environment and then respond just as quickly to any potential security events. You want to then also apply security at all layers. So when we talk about security at all layers, we're not just talking about application layer security. It's not just ensuring that your data is encrypted, both in transit and at rest, but also things like network security, the connectivity from the end user right up to the backend services within your AWS environment, that all of those connections are also secure. It's important to be able to apply security at all layers of your application lifecycle. Next, you want to automate security best practices. You want to improve your ability to securely scale more rapidly and cost effectively. And you want to create secure architectures, implement controls, and define and manage code in version control templates. The next design principle is about protecting data in transit and at rest. Briefly touched upon this a little bit earlier, but essentially we're talking about encryption and tokenization. Using encryption technologies, you want to be able to ensure that the data that is in transit cannot be eavesdropped upon, and whilst it is at rest, stored on a storage volume of some sort, that it is just as protected from any unauthorized access. The next design principle is to keep people away from data. Using mechanisms and tools to reduce or even eliminate the need for direct access or manual processing of data is one that will ensure the security of your data. This reduces the risk of mishandling or modification or any sort of bad actors maliciously changing your data. Another design principle is to prepare for security events. Now, AWS recommends that you implement game days or simulated environments so that you can actually see what your responses would be like in a potential live security issue. You want to run incident response simulations, use tools with automation to increase your speed of detection, investigation, and recovery. The reliability pillar is the third pillar in our well-architected framework, and achieving reliability can be challenging in on-premise environments due to factors like single points of failure, lack of automation, and lack of elasticity. Now, in contrast with the cloud, you can build solutions that are highly available, fault-tolerant, and scalable, and where incident response or remediation can be automated. All this can be achieved at a fraction of the cost when compared to on-premises options if you were to implement those same features within your on-premises environments. Let us look at how the design principle for the reliability pillar can help businesses. So the first design principle is automatically recovering from failure, which requires you to monitor your workload for key performance indicators and then running automation when thresholds have been breached. Now, the KPIs need to measure the business value, not the technical aspect of the operation. So this means that if you find that your users are suddenly in a position where site is being unresponsive and you need to scale out because perhaps a couple of your EC2 instances have failed in the back end. That's obviously the reason why this happened, but ultimately it has an impact on your end users. You want to make sure that those KPIs have been addressed when they are breached. You want to make sure that when thresholds have been breached, that you respond automatically and roll out a couple of new additional EC2 instances to ensure that those KPIs are being met. The next one is to test recovery procedures, which in an on-premise environment, testing is often conducted to prove that workloads work in a particular scenario, as opposed to validating recovery strategies. In the cloud, you want to test what happens when workloads fail. You want to validate your recovery procedures. And so you need to have playbooks and processes and procedures in place to simulate different failures and how the recovery from those failures actually takes place. You also want to scale horizontally to increase the aggregate workload availability, and this is critical. This ensures that you replace a large resource with multiple smaller resources to reduce the impact of that single point of failure issue that we often experience in traditional on-premise environments. Another design principle is to stop guessing capacity. So a common failure with on-premise workloads is resource saturation, when demands placed on a particular workload exceed the capacity of that workload. In the cloud, you want to monitor demand and workload utilization and then automate the addition or removal of resources using tools like autoscaling. Next, you want to manage change through automation. This is critical. This helps alleviate a lot of the administrative overhead that often makes you less agile when compared to your competitors. By automating change, by implementing scripts and processes in place so that when things are triggered, when events occur, changes are implemented automatically, you ensure that you're far more agile and reliable. So the next pillar is performance efficiency, which is all about the efficient use of computing resources to meet requirements and how to maintain efficiency as demand changes and technologies evolve. It involves making trade-offs in your architecture to improve performance, such as using compression or caching, or relaxing consistency requirements. Let's take a look at some design principles for this particular pillar of the Well-Architected framework. So the first design principle is democratizing advanced technologies. Now, this is all about making technology implementation easier for your team by delegating complex tasks to your cloud vendor. Rather than asking your team to learn about hosting or running new technologies, consider consuming the technology as a service. For example, rather than building your own media transcoding service in-house, you can make use of the media transcoding services that AWS offers. And this helps you to effectively become more agile and improve your performance in actually delivering solutions to your clients. The next design principle is to go global in minutes. You want to be able to deploy your workloads in multiple AWS regions around the world so that you can provide low latency and better experience for your end customers. A lot of businesses are global these days, especially when you're selling digital products and services, and you want to be able to ensure that you give the best possible customer experiences to your end clients. Next, you should consider using serverless architectures, which remove the need for you to run and maintain physical, or in the case of the cloud, virtual, but nevertheless servers that are under your control. Serverless technologies can support things like static websites, and event services can host code. This removes the operation burden of managing physical servers that can lower transactional costs because managed services operate in cloud at scale. Consider experimenting more often. This will improve your performance because you will be able to quickly carry out comparative testing analysis using different types of instances, storage, and configurations, and easily identify the best optimal design architecture for your requirements. Also consider mechanical sympathy, which is where you use technology approach that best aligns with your goals. Consider data access patterns when you select a database or the type of storage that you need for your specific workload requirements. Next, let's move on to the cost optimization pillar, which is pillar number 5. Now, cost optimization is all about the continual process of refinement and improvement over the span of your workloads and your application's lifecycle. You want to be cost aware of your workloads that achieve business outcomes, and you want to do so while minimizing cost of your overall application design, build, and deployments, and its running and maintenance of. There are several design principles when it comes to understanding this particular pillar. The first one is to implement cloud financial management. And this involves you investing in cloud financial management, or FinOps, where you must dedicate the necessary time and resources to build the capability within your organization around this domain of technology. Similar to how you would build the necessary capabilities around security and operations, you should do the same for cloud financial management. The next design principle is to adopt a consumption model. And this is where you only pay for computing resources that you consume, increasing or decreasing your consumption based on your business requirements. So for example, when you have dev and test environments and you know that those environments are only going to be used during working hours of the day, then you want to ensure that those resources are stopped after working hours. In other words, when your developers leave home for the day, there is no need for the dev servers to be in a running state. That will save you a massive amounts of spend and therefore allow you to adopt a consumption model more effectively. The next design principle is to measure overall efficiency. You want to measure business output of the workloads and the cost associated with delivering those workloads. You want to use the data to understand the gains you've made from increasing output, increasing functionality, and reducing cost. Next, you want to stop spending money on undifferentiated heavy lifting. This is all about ensuring that you use AWS sensibly. Instead of racking, stacking, and powering servers, you want to remove all of that administrative overhead that comes with a cost in favor of more managed services from the AWS platform. You should also analyze and attribute your expenditure. Now, the cloud makes it very easy to accurately identify cost and usage of workloads and then allows you to transparently attribute those costs and revenue streams against the individual workload owners. This helps you measure return on investment, your ROI, and gives workload owners the opportunity to optimize their resources and reduce overall costs. The sixth pillar of the Well-Architected framework is all about sustainability, and it focuses on your business activities' long-term environmental, economical, and social impact. How the consumption of cloud computing services and resources has environmental impacts, especially energy consumption and efficiency. Cloud providers like AWS focus on enabling you to do your part for the environment through its various cutting-edge services and push for fully service-based and serverless compute models. Emissions from your workloads running on AWS are accounted for as indirect emissions, and they vary based on energy consumed by those services, the carbon intensity of the electric grids serving the AWS data centers where they run, and the AWS procurement of renewable energy. Let's take a look at the design principles in this pillar. So the first design principle is to understand your impact, and you measure your impact through your cloud workloads and models by analyzing exactly what it is that you're consuming. You compare productive output with total impact of your cloud workloads by reviewing resources and emissions required per unit of work. And you use this data to establish key performance indicators, evaluate ways to improve productivity while reducing impact, and estimate the impact of the proposed changes over time. Next, you want to establish sustainability goals. So you want to ensure that your workloads that are running in the cloud are as less impactful to the environment as possible. And this means you need to evaluate the architectural design patterns of your workloads and how they can help you achieve your sustainability goals. Consider using managed services, for instance, instead of spinning your own web servers or application servers that perhaps may be sitting idle for a particular period of time and unnecessarily cause environmental damage. You want to plan for growth and architect your workload so that growth results in reduced impact intensity measured against an appropriate unit, such as a per user or per transaction. Next, you want to maximize utilization. So you want to right size your workloads and you want to implement efficient design patterns in your architectural design of your applications. As an example, 2 hosts running at 30% utilization is less efficient than 1 host running at 60% due to the baseline power consumption per host. You want to eliminate and minimize idle resources, processing, and storage to reduce total energy required to power your applications. The next design principle is to anticipate and adopt new, more efficient hardware and software offerings. AWS and other cloud providers are always constantly trying to fulfill their requirements to meet sustainability goals, and as such, you should consider evaluating your application architectures and identifying any new technologies or software offerings from your vendor to see whether it would reduce your environmental impact. consider using managed services. Sharing services across a broad customer base helps to maximize resource utilization. And this means that you can actually reduce your individual power consumption, your individual resource consumption, if you're sharing backend systems with other customers. Remember, AWS offers high levels of security to ensure isolation between customer environments. An example would be to consider using AWS Fargate for serverless containers, as opposed to having your own container services deployed in the cloud. Finally, consider reducing downstream impact of your cloud workloads. Reduce the amount of energy or resources required to use your services. Reduce or eliminate the need for customer to upgrade their devices to use your services. Test using device farms and understand the expected impact, and test with customers to understand the actual impact from the use of your services. So that brings us to the end of the 6 pillars of the Well-Architected framework. As you can see, each of these pillars provides certain best practices and guidelines to help you ensure that the applications you are designing, building, and deploying on the AWS platform are highly reliable, fault-tolerant, high-performing, scalable, cost-effective, and of course, fulfill sustainability and environmental goals. So next, I wanted to talk to you about the Well-Architected tool, a tool that's been designed to help you fulfill the requirements of the 6 pillars by following a series of questioning against your workloads across those 6 domains. The Well-Architected tool makes it a lot easier for you to actually get started and use the Well-Architected framework so that you can ensure that the products and services that you build for the cloud is aligned with those 6 pillars. Now, the Well-Architected tool is designed to help you document and measure your application workload using the best practices from the Well-Architected framework. And the tool enables you to understand the best practices to follow and helps to address risks in your current application architecture through a series of questions across those 6 pillars. Through supported documentation and video guides, you can also gain an understanding of why a particular recommendation is important for your workload, as well as the architecture references to help you implement those recommendations. Now, there are key 3 benefits of using the Well-Architected tool, and the first one is to get architecture guidance. This allows you to access the knowledge and best practices used by AWS solutions architects and get guidance on how to design and operate workloads that are reliable, secure, efficient, and cost-effective. Another key benefit is enabling consistent governance, which is where you can apply a consistent process to help you review and measure your cloud architectures. You can understand the potential risks in your workloads and use the results to review and identify the next steps for improvement. And the third key benefit is the ability to continuously improve architectures. There is support for continuous improvement throughout the workload lifecycle. You can easily save milestones of your workload reviews and track changes as your architecture improves over time. Whenever you require, you can initiate a new review process to help you ensure that the architecture is aligned with the latest AWS best practices. In order to better understand how the Well-Architected tool works, let's talk about workloads and lenses. So workloads are essentially a collection of resources and application code that delivers some sort of business value. For example, an e-commerce website. Workloads may consist of a few resources in a single AWS account or many resources spanning multiple AWS accounts. You can share your workload that you own with other AWS accounts, users, organizations, or OUs, all within the same AWS region. Now, when it comes to a workload, you want to run the Well-Architected tool against it to identify whether or not it fulfills and aligns with the Well-Architected framework and the 6 key pillars. This requires you to run it through what we call lenses. And there are different types of lenses that you can use. Lenses provide a way for you to consistently measure your architectures against best practices and identify areas of improvement. A lens is essentially a best practice checklist that you want to measure your workloads against. By default, there is the Well-Architected lens, which AWS provides, that is applied to all of your workloads when you first set up the Well-Architected tool that you are trying to run. This is applied by default, and it measures your workloads across those 6 key pillars. Each pillar posing several questions against which you analyze and identify how your workloads fulfill those recommendations, whether applied or missing from your workload design and configuration. Similarly, AWS offers you other lenses as well, such as serverless application lenses, where you look at certain best practices that is ideal for RESTful microservices, mobile app backends, stream processing, and web application. Another lens is the SaaS lens that is focused on designing, deploying, and architecting your software as a service solution on the AWS platform. There's also the SAP lens, which is design principles and best practices for SAP workloads on the AWS Cloud. And you can also define custom lenses, where you can create custom pillars, questions, and best practices along with improvement plans, and then apply that custom lens to your workload in the same way as you would one of the pre-existing AWS lenses. Once you've applied your lens to a workload, you can create what's then called a milestone. Now, a milestone is simply a state of a workload at a particular point in time. You can save this milestone after your initial analysis against those lenses, and you can change your workloads and its configuration based on the improvement recommendations of those lenses so that you upscale your workloads to be aligned with those best practices. The important thing to understand here is that when you create this milestone and you run your lens against your workload, what you get as an output is actually a breakdown of the current risk factors that AWS considers is in your workloads. And these are broken down into high risk factors and medium risk factors. And so ultimately you get a number of different items that will be highlighted as high risk elements across the pillars. So in the case of the well-architected lens, across those 6 pillars, and as well the number of medium risk factors that you need to address. You then go back to your workload and make the necessary changes, configure your workloads and your applications in a manner that fulfills the requirements of the lens that you are running against it. And what happens then is that you rerun the lens against those workloads again. And this time, hopefully what you get is a better outcome, a better milestone, a milestone that has achieved some of the recommendations of those lenses. And ultimately, your aim is to try and reduce the risk factors from what it was earlier to 0. So you run through the same process again, you keep going through, you actually analyze your workloads, you identify areas that you need to perhaps do a little bit more work on in terms of configuration, in terms of the way in which the application functions, and you go ahead and apply the same lens again and run your lens and analyze your workload against those lenses to ultimately get a fully functioning workload or milestone that has 0 risks, both for your high risk factors and minimum risk factors. That's the ultimate target that you are hoping to achieve. So this entire process is something that you and your team members need to work on in order to ensure that your workloads and applications that you design and deploy on the AWS platforms fulfills the requirements of those pillars that are identified in the lens. In the case of the well-architected lens, there are 6 pillars to be aware of that you need to run your workloads against. And obviously, you can even create your custom lenses if there are some specific bespoke pillars that you would like to ensure alignment against. Okay, so next what I wanted to do is take a look at some typical sample exam style questions that you may encounter in the AWS Cloud Practitioner exam, which I think will be beneficial to help you understand how this particular module is tested on the official exam. So let's do that next. Let's take a look at some sample exam questions next. So the first one, question number 1, is which of the following are design principles for the well-architected sustainability pillar? And you're required to choose 2 answers. And hopefully you are aware that on the exam you're going to get both multi-choice questions and multi-select questions. Multi-select questions are usually a question with 5 answer options, and you get to select 2 that are correct. So in this one, we're going to be selecting 2 answers. So the first answer option is to use managed services. The second one is maximizing utilization. Prepare for security events. Make frequent small reversible changes. And the last option is consider mechanical sympathy. Now, in terms of the sustainability pillar, you would need to know the various design principles of the sustainability pillar. And so the answer, in fact, for this particular question would be A, managed services, okay, because you want to be using managed services in order to enable you to maximize on resource utilization and underlying infrastructure utilization. And the second answer is B, maximize utilization, which is all about ensuring that you make the most of the various resources that you have provisioned, that you don't have resources lying idle around. So correct answers are A and B. Answer C is incorrect because security events, well, that's to do with the security pillar. Answer option D, make frequent small reversible changes, is also not part of the sustainability pillar. In fact, it is part of the operations pillar. And then you have answer option E, which is consider mechanical sympathy. That too is an incorrect answer. Mechanical sympathy actually is part of the performance pillar. And if we take a look at the sustainability pillar, you will see, in fact, yes, maximizing utilization is one of the answer options, as is using managed services. Okay, question number 2. Which AWS service enables you to review the state of your applications and workloads against AWS best practices by answering foundational questions with the option to create your own custom lenses? And your answer options are Trusted Advisor, Personal Health Dashboard, Well-Architected Tool, AWS Inspector. Now, by knowing the features of the Well-Architected tool, the custom lenses, the milestones, etc., you would hopefully have answered this question with the answer option C, and that would be the correct answer. Okay, let's move on to question number 3. Which design principle represent best practices as described by the reliability pillar of the AWS Well Architected Framework? Here again, you need to select 2 answer options, and so you'll be given 5 options to select from. The first one is perform operation as code. Now that should be a dead giveaway. Operation as code is part of operational excellence, not part of the reliability pillar. Answer option B, automatically recover from failure. That is in fact a reliability pillar design principle. So answer option B is correct. Scale horizontally to increase aggregate workload availability. Again, the whole idea behind the reliability pillar is to ensure that your workloads are reliable. No doubt there. And when you're scaling your workloads horizontally, basically what you're doing is you're spreading your workloads potentially over multiple availability zones and even over multiple regions, and therefore increasing the reliability of your application stack. So C is also correct. Answer option D is using serverless architectures. Now, serverless architectures falls within the performance pillar, okay? And the reason is that AWS manages the performance of every managed service for you. Okay, so you don't have to worry about, provisioning your own EC2 instances, making a decision about how much RAM you need, how much CPU utilization you need, and if you are having a lot of traffic come through, having to upgrade that. By using serverless architectures, your performance is taken care of by AWS themselves. Answer option D is therefore incorrect. Now, answer option E is to adopt a consumption model. And a consumption model is all about ensuring that you pay only for what you use and what you consume. And this therefore refers to the cost optimization pillar, and therefore an incorrect answer as well. So the correct answer here is B and C. Okay, automatically recover from failure and scale horizontally to increase aggregate workload availability. And if we take a look at the reliability pillar, you will see, in fact, yes, automatically recover from failure is one of the design principles, as is scaling horizontally to increase aggregate workload availability. Right, okay, so that brings us to the end of this video, and in fact the end of this module. I hope you found this particular video very useful in giving you an insight into the sort of questions that you may see in the exam. Thank you.